Hi, this is Albert Ali Salah from Boğaziçi University. I'm sorry that none of us were able to attend the conference because of some visa issues, but I will be presenting you our joint work with Güney Kayim and Ekberjan Derman. This work was jointly performed with Provus, which is acquired by MasterCard and which is the largest supplier of ATMs in Turkey. And Güney and Ekberjan um, were employed by Provus at the time. And the title of our work is Short-Term Re-Identification of Automatic Teller Machine Uses via Face and Body Appearance Features. Let me start with the motivation of our study. Card and cash forgetting is a major problem for automatic teller machines. When a customer forgets a certain amount of cash in an ATM, the machine will typically retract this money, in 20 or 30 seconds. And then this money will be taken out of circulation until a bank employee comes and counts this money manually. MasterCard estimates that a single ATM has around 10 card retractions and around 16, 17 cash retractions per year. And for a country like Turkey, where we have about thousands of ATMs around, the estimated loss is over several $1 million per year. Our project is to mitigate this issue by allowing the customer to return to the ATM to get back the forgotten items. That means we want to extend the card and cash swallowing time from 20 seconds to, say, 1 minute. And we also want to re-identify the user to allow that particular user to get the cash or the card and not someone else. In the proposed system, as soon as a customer inserts the card into the ATM and a session is initiated, the system starts to perform face and body appearance detection using the camera located near the ATM and builds a temporary identity database for the customer. If the customer leaves the ATM without taking his or her card or cash, the ATM waits for the customer to be back instead of retracting the forgotten item. If the system finds out there is a different customer approaching the ATM before the actual card or cash holder, the item is retracted instantly. This scenario is fundamentally different than biometric authentication scenarios, in which a person's image is matched to a gallery image acquired possibly a long time before the matching and under different conditions. In this scenario, the matching image and the gallery image are separated by mere minutes at most. And also, planned attacks are very unlikely because an imposter cannot wait for a card or cash forgetting to happen. These only happen a couple of times a year per ATM. On the other hand, the main difficulties are the uncontrolled and low quality real-world images coming from the attached ATM camera and the extreme lighting conditions. Moreover, the processing and decision-making should be carried out in a very short time frame to be of practical use. Furthermore, because of banking regulations, we cannot store in-session data. So once the session is over, all the data we record must be discarded. There is little related work in this new biometric scenario. Camera-based biometric identification at an ATM is difficult. Hence, it is mainly used for additional security in a multimodal fashion. In almost all scenarios, the face image is compared to a gallery image acquired in different conditions. Derman and colleagues previously proposed face verification for short-term re-identification in a card and cash forgetting scenario, but they used only the face modality, which did not perform very well. In this work, we propose to combine face with appearance features. In our scenario, once a user is in session, the camera images are acquired and features are extracted to build a temporary database of the user. Once the session is over and we know that cards or cash is forgotten, then we start again using the camera images to do feature extraction, and then use the online built classifier to decide whether a person approaching the ATM is the user which initiated the session or not. If there is no card or cash forgetting, then the default behavior of the machine is exhibited. The effective working of the system is then to track whether a user comes back to the ATM within a certain waiting period, and if the verification happens, then the user is allowed to take the item. If the verification doesn't happen, then the item is retracted. One of the things we have experimented with during the studies is where to place the camera to recognize the person. And because ATMs have different styles and different shapes, the camera placement cannot be very uniform. Finally, we decided that a profile view would be the most ideal. One of the banking regulations dictates that whatever camera you place on an ATM cannot actually see the keyboard, so that the password remains hidden. These are two examples from the ATM lab at Provus from our camera placement. Our proposed approach is to use a face verifier in conjunction with an appearance verifier, which looks at the body of the person, and then the two verifiers are combined with a simple score fusion module. The assumption is that since the re-identification happens within a minute, the user is still wearing the same stuff. Let me start with face verification. As you will see, we have used very simple approaches in this work. We have used OpenCV's Viola-Jones detector for face detection, and we used the cascade for left profile faces. We have tested multiple rotations of the image. Basically, in 5-degree increments, we've tested from 0 to 40 degrees rotations so that tall and short people can be accommodated. For pre-processing, we cropped the face mask, we did a Gaussian smoothing, we resized the images to a fixed 64 by 64 matrix, and then we performed an histogram equalization. For a classifier, we trained support vector machines. For feature extraction, we use LBP features on subregions extracted from the face. We concatenated them and gave them to the SVM. Now, the positive samples are the in-session images of the user, and typically these are on the order of 1,000 images. For negative samples, we can have a pre-stored image database at the machine, but that comes from an external database and has around 600 images in our case. For test samples, we're going to test out-of-session images. That means what happens when the user is returning to the ATM. Now, during this out-of-session images, during the collection of these, the user is in motion. He or she is approaching the ATM, so we have motion blur and different scale issues. For appearance verification, we select a 50 by 50 region relative to the detected face area to model the clothing appearance of the user. The background model is learned by a Gaussian mixture model with diagonal covariances that uses 10 components. Once we detect the face, we can determine the green box in the image that shows you from which area we're extracting the clothing features. We're just doing plain likelihood modeling here to determine whether the box actually comes from the returning customer or from something else. Once the individual classifiers give their decisions, their votes are combined with a weighted sum rule. Again, we're using a very simple, very straightforward multimodal fusion scheme here. To test our approach, we have collected an in-house database. We have used 57 subjects, balanced gender, between 160 and 190 centimeters tall, based on a scripted cache and card forgetting scenario. In this scenario, the session is started by the user, who then forgets one of the items, goes away from the ATM, and then after some time comes back to it. Now, for all in-session data, we have quite a few frames, about 1,000 in this case. But the out-of-session data is much faster, much smaller. And motion blur appears to be the biggest challenge for face matching. We have tested two different scenarios on this database. The first scenario is the two-class classification, where an out-of-session image set is matched to the in-session positive samples. And we have two classes, either the matching identity, a positive class, or a negative identity, an imposter class. All the remaining subjects in the training set act as imposters for a given subject. For the second scenario, we actually tested images with in-session images instead of out-of-session images. We wanted to see the effect of image quality on algorithm performance, because the out-of-session images are very low quality, have a lot of motion blur. What happens if we use an unused but in-session image to verify the customer? Here you can see the ROC curves of the proposed system. On the left, the first scenario where out-of-session images are matched to in-session images, and on the right you can see the in-session images matched to other in-session images. What you can see clearly here is that image quality, low image quality, is a big determinant of success here. We can obtain much higher genuine accept rates at a given false accept rate if we have images that are free of motion blur. If we use only face verification, we get a false acceptance rate of 5% with a genuine acceptance rate of 81.5%. If we use both face and appearance verification, we can reach a 91% genuine acceptance rate at a false acceptance rate of 5%. Well, in a cache and card forgetting scenario, there can hardly be any intentional attacks on the system. So a much higher false acceptance rate than an ordinary biometric scenario should be acceptable. Besides, there is always the ATM camera to record whatever is going on around the ATM. The fused system gives better performance than any single module, and we can see that the image quality results in a marked increase in the system performance. This system is very simple. So it works at 15 frames per second on the ATM, which has a Intel Core 2 Duo 3 GHz CPU with 2 GB of RAM, a Windows XP Pro operating system. If we look at some of the failure cases, both acquired from indoor and outdoor scenarios, we can see that face detection sometimes fails because of garments, occlusions, hair or beard even. When the face is not detected, the default ATM behavior is exhibited. In conclusions, the proposed system seems to be promising for mitigating the card and cache forgetting issue. We can consider much more complicated algorithms, but we have to stick to the limits of hardware given by the ATM platform. So the current system assumes very low-cost hardware for both image acquisition and processing. Motion blur is an important issue for the verification of the returning customer, and that issue is probably solvable by using a newer sensor, which is currently not available for installing on the ATM. And for future work, we're also thinking about dealing with multiple faces in the scene problem, which is currently not dealt with at all. This concludes the presentation of this work. The first two authors, Ekberjan and Güney, contributed equally, and the work is partially supported by the Scientific and Technological Research Council of Turkey. So let me acknowledge these here. And for questions and comments, I'm sorry that I'm not there to get them, but you can always contact me via email. Thank you for listening.